Welcome to the concentration and dilution video. By the end of this video, you should understand the difference between concentrated and dilute solutions, be able to perform calculations using the molarity equation, know what it means to perform a dilution, and be able to perform calculations related to dilutions. First, let's consider the more general term, concentration. Concentration is the amount of solute in a given amount of solvent or solution. In other words, it's a ratio between the solute and the solvent in a solution. There's lots of ways to measure concentration. We're only going to focus on one of them in this class. First, let's look at some terms we usually use to qualitatively, not quantitatively, but qualitatively describe solutions. First, you might describe a solution as concentrated. This means there's a relatively large amount of solute as compared to the solvent. For instance, strong coffee or strong Kool-Aid would have a whole lot of coffee or Kool-Aid as compared to the amount of water. Compare this to a dilute solution, which has a relatively small amount of solute as compared to the amount of solvent. For instance, weak coffee or weak Kool-Aid. Giving the example of coffee and Kool-Aid, things that also have a color associated with them, you can imagine that as they become more concentrated, as you get more and more solute in the solvent, they get darker and darker in color. Now let's quantify concentration. So we're going to use the unit of molarity to quantify concentration. There's lots of different ways you can quantify this. This is the one we're going to focus on. So molarity, abbreviated with a capital M, is a unit of concentration describing the moles of solute as compared to the liters of solution. In other words, the equation is molarity equals moles of solute over liters of solution. This is often just abbreviated as molarity equals moles over liters. Let's look at a couple of examples of these calculations. Let's calculate the molarity of the following solutions. In the first example, we're asked to calculate the molarity of a solution that contains 5 moles of sodium chloride dissolved in 0.050 liters of solution. I'm going to start by writing down my molarity equation. Molarity equals moles over liters. From here, I can plug in directly from the problem. I'm told that I have 0.5 moles of sodium chloride, that's my solute, and it's dissolved in 0.050 liters of solution. Dividing 0.5 by 0.05 gives me 10 molar. Notice it's 2 sig figs, so the decimal point is there to indicate that that zero is significant. Here's another example. In this example, we're asked to calculate the molarity of a solution where 5 grams of barium chloride is dissolved in 0.050 liters of solution. Notice in this case, we're not given moles. We're given grams of solute instead. So our first step needs to be to convert our grams of barium chloride into moles of barium chloride. As usual, I'm going to do that by dividing by the molar mass or setting up a proportion using the molar mass. The molar mass for barium chloride, which is BaCl2, is 208 grams per mole. So, converting 5 grams of barium chloride to moles gives me 0.024 moles of barium chloride. Now I can plug it into the molarity equation. 0.024 moles of barium chloride divided by 0.050 liters of solution gives me a molarity of 0.48 molar. Here's a few to try on your own. Pause the video here, and when you return, I'll reveal the answers. Welcome back. Here's what you should have gotten. Notice in the first case and in the second case, you had to convert your grams to moles before plugging into the equation. In each of these cases as well, I gave you milliliters, so you needed to convert to liters because the denominator is in liters. You have to be very mindful of your units when doing these calculations. And then finally, in number 3, here you're given the molarity and asked for the number of moles. So this is a little bit different. We're solving for moles instead of molarity, but the equation works just the same. Sometimes, instead of being given a solution that you need to make from scratch, You're given a solution that already exists and asked to dilute it. A dilution is the addition of water to a stock solution to produce a solution of a new molarity. In other words, this would be a case where I'm given a solution that's already made. The solute is already dissolved in the solvent, but I want to turn it into a different solution with a lower molarity, so I'll add some water to it. The stock solution is just the concentrated solution. It's the one I already have on hand. During a dilution, it's important to note that the number of moles of solute remains constant. I'm not changing the moles of solute. I'm not adding or removing any solute. I'm only changing the volume by adding water. Since I'm adding water, I'm increasing the denominator. The numerator remains the same, so my molarity is going to decrease. There's an equation to represent dilutions. Here it is as M1V1 equals M2V2. M1 being the molarity of the stock solution, V1 being the volume of the stock solution that you need, M2, the molarity after the dilution, in other words, the molarity of the solution I want, and V2 is the volume of the solution after the dilution. Here's an example that we'll try together. This question says, calculate the volume of 0.200 molar NaCl solution necessary to produce 500 milliliters of 0.0500 molar NaCl solution. So notice here we're given a solution of 1 molarity and asked to turn it into a solution of a different molarity. Notice that this is different than making a new solution from scratch when we dissolve solute in solvent. So I'm going to use my dilution equation since I recognize that I have one solution and I'm going to make a new one from it. And I'm going to plug in the things I know. I know that the molarity of my initial solution, M1, is 0.200 molar. I don't know the volume of that I'm going to use yet. I'm going to use some amount of that solution to make my new solution. I'm going to produce 500 milliliters, which is my V2, of 0.0500 molar solution. That's my M2. Doing this math, I find that V1 is equal to 125 milliliters. In other words, I need to use 125 milliliters of the original solution to make my new solution. Now, of course, a dilution involves adding water, so what's the rest of this solution going to be? Well, it's going to be water. I'm going to take 125 milliliters of my original stock solution and then add water until it gets up to 500 milliliters. Here's 2 to try on your own. Pause the video here, and when you come back, I'll reveal the answers. Welcome back. Here's what you should have gotten. In each of these cases, notice you're solving for the initial volume. That's the volume of the stock solution you need to use to make your new solution. In each case, then the remainder of the solution would be water. So in the first case, you'd use 0.1 liters of the stock solution and then add water till it gets to 1.5 liters. Here, you'd use 0.015 liters of the stock solution and add water to get it to 0.75 liters. It's also worth noting that unlike molarity calculations where you have to use liters in your denominator, in a dilution, you can use milliliters or liters as long as the volume on both sides is in the same unit. So if V1 is in milliliters, V2 must be in milliliters. If V1 is in liters, V2 must be in liters. It doesn't matter which one you use, but it has to be the same on both sides. That brings us to the end of this video. Let's review our goals. First, we looked at the difference between concentrated and dilute solutions. Then we performed calculations using the molarity equation. Molarity equals moles over liters. Then we looked at dilutions, which take an existing solution and add water to give you a more dilute solution. And then we performed calculations related to dilutions using the equation M1V1 equals M2V2.